Good morning, everyone. Welcome to Pamplona. My name is Sonia Muro. I'm the responsible of sustainability in Florette, Spain. I'm going to introduce you our pilot case. It's the number 2. Okay. First of all, I'm going to speak briefly about Florette. We are the main producers of ready-to-eat salads, which is called for range in Spain. We are not only producers as packers, we pack salads, but we are our own farmers. We produce also our raw materials. And CoFresh for us is an opportunity to develop practices more sustainable, from the fields to the packaging materials. And after a brainstorming session, participants selected 3 innovations in which focus our project. Innovation 1 is focusing sustainable packaging and active packaging films that extends the product shelf life of our products. I will present this innovation myself. Innovation 2 refers to digitalization of services from the use of fertilizers according to soil needs, nitrogen, potassium, and sodium. Harris from Fint will explain you this innovation. And finally, innovation 3 is focused in the reuse of washing water, and Eva Petri from CNTA will explain you this innovation. So, innovation 1, sustainable packaging and active packaging film that extend our products' shelf life. Why this innovation? Well, because we know that nowadays market, consumers and law are asking for more sustainable packaging and reduction of plastic consumption, mainly virgin plastics or virgin materials. And in addition, our product has a very short shelf life and it's not possible to reach all markets with a good quality. To test the innovation, we focus in our salad classics, which is a mix of different baby leaves, and that currently is packed in a polypropylene 30 microns. It was always the control against we compare the different materials. We have tested different packaging solutions. In fact, we have tested 4 different materials. The first one is a material made 100% paper. We had bad results, sorry to say that, because the material has a high gas permeation, we will say poor barrier to gas, so we lose a lot of humidity and salads was not good at the end of the shelf life. The second solution, or the second material, was a bio-based and biodegradable material. We had good results with this material. Third one was a OPP, biodegradable and also recyclable, with good results in the salad conservation. And finally, we test an polypropylene which has the capacity to absorb CO2 and humidity. But we had also bad results. We didn't have too much time to test different absorbers concentrations. Maybe we need to work in this way and to test other concentrations that we could have better results. But at this step, we only can say that the test made was not good. Which is our value proposition? We think that paper, bio-based and biodegradable materials are more sustainable options than conventional fossil plastics and could be a real and feasible materials to pack salads. But gas permeation of materials is crucial in the salads conservations, and we have problems mainly with the paper. Good sealing and machinability is very important in the performance of the materials, and we have problems also with the handling of different materials. So some improvements and modification in the materials is needed to have good results in all the chain. Our next steps will be go on testing with film with absorbers. As I said, maybe changing the additive concentration. Evaluate if we are interested in looking for ways to improve the permeation in paper, because paper has the disadvantage of being not transparent, and this is a very valued aspect in our packaging for the consumer. And calculate if we could afford the extra cost and the risk of supply of biodegradable polypropylene.
Hello. I'm Haris Moisiadis from Future Intelligence. We worked in Letera di Zoe pilot, and now you're going to see our work in Florette case, along with the support of CNTA. We try to digitally transform how fertilization management occurs by introducing a new kind of sensors and create new prototypes. So the problem is that fertilizers cost a lot for the farmer. They also have a negative environmental impact, and not all of fertilizer applications are effective, are doing the right thing. To add, experience-based farming, even in greenhouse context, it's not easily to continue working because we have changing weather patterns. Thus, I mean, things that we did the previous year is not always the good way of working. To add, low-cost technologies have emerged, and we see the law of more still continue. So hardware is getting cheaper and cheaper. So we tried three different, and we're still trying three different kind of solutions. The first two had to do with a prototype of new sensor stations, new devices that incorporate nitrogen, phosphorus, and potassium sensors in the first case, and soil pH in the second case. We managed to run these scenarios in the second cultivation cycle that you will see below, and now we are in the process of using traditional state-of-the-art sensors for optimizing fertilization management. So Kuhoma is the solution, the smart farming solution that tries to reduce farm inputs for the farmers and maximize their yields with the introduction of hardware and software that we build ourselves, not the sensor, but the telecom part. And we managed to run 3 cycles. The first one from April to May was a bit to assess the conditions in the 2 different parcels within Florette greenhouses. So from June, late June to early October to early August, we used the new prototype devices to compare values and reduce fertilizers. So we reduced fertilization by 25%, but we had a less yield by 21%. So this proves that on one hand, fertilization management is quite optimal, the way it's done by Florette colleagues for now. And the other one is that the sensors themselves are not still very credible. The measurements that we get are not very reliable. And we are now working on the 3rd cycle from early September to mid-October. So we don't have any results there yet. The rationale there is to reduce irrigation in terms of in order to make the plant more capable of absorbing the nutrients. And yeah, we'll see what happens. So mid-October, we have some initial results. And of course, because we ran already some data analysis for the credibility of sensor measurements, we are not very happy with the results that we got. So we keep an eye to see what's coming next in terms of the sensor manufacturer market.
So, good morning and welcome everyone. Let's go into detail innovation number 3, the reutilization of washing water, where the innovation leader of this activity has been CNTA with the support of Univo and Florette. So, which is the problem we want to solve and why it's important? Well, in this picture, we have represented the typical diagram flow of a fresh cut vegetable where the product is immersed into a washing tank where there is a flow, and also this water contains a disinfecting agent that conventionally it's chlorine. This step is really needed since most of the fresh cut vegetables are consumed uncooked. And afterwards, after a washing time, the product is carried outside the tank and it's rinsed with clean water in order to remove the potential disinfection byproducts that can be on the surface of the product. So among all the processing steps, the washing disinfection is the most critical one due to its crucial impact on the safety and quality of the produce and also on the environmental sustainability of the whole process. So the objectives of innovation actions carried out have been to find a sanitizing alternative with an antimicrobial effectiveness at least equal or higher than conventional one, and also to find out if it's possible to reduce the rate of water turnover and the water consumption needed for the whole process, since this process requires the use of large quantities of water. So the solutions that have been proposed for addressing this problem have been 2 different alternative technologies, such as hypochlorous acid and also plasma technology. Regarding the first one, these are the main conclusions that we have obtained under the experimental studies conducted. So from the product safety point of view, we have comparable antimicrobial efficacy by the use of hypochlorous acid and also chlorine application. But however, in our study, washing with hypochlorous acid resulted in a higher accumulation of disinfection byproducts in the processing water. As regards to environmental issues, this agent has not been proved effective in reducing water turnover and water consumption rate, since this agent is dependent of organic matter content in the washing water, making necessary, as in the case of chlorine, a continuous water refreshment in the washing tank. And also, this agent poses a residue problem since it generates also specific byproducts, therefore the rinsing step cannot be avoided. And another disadvantage is the relatively high initial cost, although we know that the performance information that we have been obtained from experimental studies at lab scale. We already know that is poorly representative of the corresponding ones at industrial level, but it's the information that we have. And regarding plasma technology, a proof of concept demonstration to verify if this technology can achieve the intended goal was tested, and different applications were tested to evaluate the microbial efficacy. On one side, we tested for water decontamination. We made different applications. We studied on dirty processed water, also on clean water, and we also studied the baby leaf lettuce wash in plasma-treated water. And on the other hand, we generate plasma and inject it inside the food bags in order to know if it was possible to extend the shelf life of the produce. So the main conclusions that we obtained is that it's strongly affected by the intrinsic characteristics of the processed water, the high organic content and the microbial load. Therefore, it's not a promising alternative for water decontamination. But on the other hand, we found that it seemed to be more powerful than chlorine in retarding the growth of surviving microbiota of produce over storage, thus increasing its shelf life. And regarding the plasma injection, no improvement of the shelf life of the product was observed in comparison with the control samples. So our value proposition is reducing the water consumption while ensuring the safety and quality of baby leaf lettuce. But the innovative technology tested does not seem to be as promising alternative as expected in the theoretical approach, and neither the POC demonstration with plasma technology. So the next steps, well, we know that the disinfection alternatives must be better and, if possible, cheaper than the existing ones to find a place in the market. And further research on sanitizing alternatives for a more safe and environmentally sustainable production of fresh cut produce is recommended. And for plasma technology, also further research towards a higher scale would be needed to better understand its efficacy in retarding the microbial growth and how much the shelf life of the produce can be extended. So that's all from my side. Thank you very much.